looks like that, and we should solve for x. Now, before I jump into what Corey was giving us, sometimes, yes, this is what Eric was concerned about. Sometimes you ain't got to clean it up a little bit first. So what do you think this is calling for you to do first, the way it looks? Divide by -3. If I divide by -3, gotta be careful.
Flip the sign.
Exactly, but at least I gotta do that. These will cancel. So you're going to end up with absolute value of 4x plus 6. Several reverses. Done. If you divide by negatives, the inequality symbol flips around, so watch out for that on the test tomorrow. Now I can go to Corey. Now Corey says if it looks like that, if I erased all that beautiful work we did earlier, guys, quickly, how would that look now with the absolute value bars dropped, and tell me what it means.
-9 is less than 4x plus 6, which is less than 9.
That's exactly what I want to hear. The bars are gone. That's what it means. Now if I solve this fairly quickly, guys, I'm going to subtract 6 from all three parts. No problem there. We end up with -15. Here this cancel, 4x. Looks like a 3 there. And then divide through by 4. Thank goodness that's a positive 4. And we end up with -15/4. Watch my math here. 4's canceled. And 3/4. If all that is done correctly, there's the answer. That's my answer. I'll ask you tomorrow to put this in interval notation, of course, which is no problem. Put this in interval notation. We're going to put it like this as the solution is parenthesis, -15/4 up to 3/4. You're done. No problem. No problem. And then, let's see if I can have this correct here. Yeah, I'm going to do one more, because it's basically I work the same way. But this one's a little different. It looks like this. Make sure it's right here. Oh yeah, absolute value. 1 subtract 4x. John will remind me, was this one on there or not? This one.
Yeah,
It was?
yeah, it's E.
Okay. And they want you to solve that. So what's the first thing you're gonna do? Not Corey. You gotta subtract that, you gotta pick this up, we're gonna subtract that 7, move that 7 over by subtracting, now you're gonna have this. Is less than -5. Now tell me before the break, what should I say here? And be careful. I know if you, as soon as you see a negative, you may think, oh, professor, there's no answer.
No, it would be
Think about that visual. I erased the graphs in there. This means you got a V-shaped graph.
5 is less than 1
Hang on. This is a V-shaped graph. You know what a V-shaped graph looks like? We had that. It says, when is it below -5, where -5 is down here?
No solution.
No solution. Makes no sense. Can't work it. Now, I'm going to turn it around just to point out something. That one's finished. If, it'll come out to be this. Now, when is that red V-shaped graph above -5, where -5 is down here? Is it always going to be above?
Yes.
Now, the answer would be
All real numbers.
all real numbers. So don't confuse those two. My last one, I thought that was the last one, it's not. The last one looks like this, which is going to be easy. Absolute value of x squared plus 2x. Is less than 15. I'll let that serve as my last one. Corey, can you tell the class with your work? Can I set that up pretty quickly and just drop the absolute value bars and just say what it means?
Do
2 is,
No, something easier than that. Recall what you said beautifully before the break on the absolute values. And by the way, I'll remind you, does this one look like, I think I have mine written like this. Does it take that form?
yeah,
Look at that board.
so X is less than A.
Yeah, oh, I got you. Yeah, X is less than negative A. Or is X caught between negative A? I think we went like this.
It would be negative 15 is less than x squared plus
Okay,
2x.
I think we went like this. And then I think Eric's telling me what it looks like here applies to my problem. I think it's what we wrote before the break.
Yeah.
And before Eric tell me again what this right here would look like if the absolute value bars dropped.
Negative 15 is less than x squared plus 2x, which is less than 15.
That's exactly right. The bars are gone. Trouble. Yeah, we got trouble here. Trouble is, it's gonna be a quadratic. I got big time problems here. Now guys, can I just leave it like you see it right now and go back and do this business here? I wish I could. Here I just put a -6, -6, and start cleaning it up. What am I gonna do here?
You have to factor it.
I'm gonna factor eventually. So what, tell me, second factor. But I can't clean it up like I did that last one.
You could then
Gotta do something else. We have an idea.
Break the equations apart into two.
Oh, we're gonna split it up. I have one that Eric gave me, I'm gonna use black here. Guys, one, Vanessa, thank you. She says, Professor, if you split this up, one part looks like this, we'll come back to it. Sometimes you gotta split this thing up. And I'm gonna use the word and. Now, there's another part. And Vanessa, tell the class what you think the other part is.
X squared plus 2x is less than 15.
I'm doing mathematicians in here. X squared plus 2x is less than 15. She is absolutely correct. There they are, at least split up. I had to do this because it's quadratic. Wasn't as easily done as that last problem over there. Now guys, gotta deal with each one. Well, you said the red one, Professor, I can deal with the red one pretty much. Let's jump down to the red one first. I can move that 15 over, Professor, and make this look more like something we've done in class in another section. Factor, Jonathan mentioned factoring way back, x plus 5, x subtract 3, no problem. And then someone in this class tell me what you would apply now so I can finish it up.
Zero product.
Zero product factor, which will give me, if I split this up, these will be my critical numbers. I'll slide that in. Those are my so-called critical numbers. Now, what would you use that you had to use on the first test on some problems? Sign analysis. You go to a number line. Put those two critical numbers, -5, 3. They will be open but not included. And here goes, I'll remind you, just in case you see it. Tomorrow, it's the old sign analysis. The guys out to the left of -5 and quickly try -10 myself. By the way, some of you guys did such a beautiful job on the sign analysis on that last test. In between, we'll try 0. Down here, we'll try 4. It's up to you. -10, I'm gonna put it right here. -10 plus 5 gives me a negative. -10 subtract 3 is a -13. Negative times a negative is a positive. Let's try 0. 0 plus 5 gives me a +5. 0 subtract 3, the sign is negative, -3. Altogether, that's negative. 4 plus 5 is 9, positive. 4 subtract 3, of course, is a +1, and I get a positive. Now, what am I looking for based on that symbol?
Less than zero.
Less than means negative. So I have discovered by sign analysis, this is your answer. There's your answer. For this one, put a comma here. -5 up to 3. You're showing all the work. But I think hang on, guys. I got the red one done. When we split this up with Vanessa's help, she said also, Professor, when you split this combined up into those two separate ones, like she did so nicely for us, there's another one here to consider. I haven't considered this one. Let's try to consider it. Jonathan, what would you do on the black one in an attempt to solve it? We got the red one out of the way.
Would you move the 15 over?
I would.
15?
Absolutely. Or, better yet, let me turn it around just to make,
Yeah.
might look better to turn it around like that. What you said is perfect though. We're saying the same thing. X squared plus two x plus 15 is greater than 0. Johnson says 0 is less than, we're saying the same thing. I think it looks better like that. I will tell you ahead of time, this is not gonna factor.
Okay.
I tried quadratic formula, now watch what happens. If I try quadratic formula, you're gonna end up with -2 plus minus square root 4, subtract 4 times a times c. I think I can stop right there because I think underneath here is a negative. Is that true? Which might say, stop, Professor, it's not working out, there are no critical numbers on this one, like I got critical numbers here, on this one, on the red one. The black one, because of that negative, I can't use sign analysis because I can't place anything on a number line. There's not anything. Can anyone tell me what I should be cautious about though, just in case? I realize there's no critical numbers on the black one. And in other words, it does not touch the x-axis. That's what it says, there are no x-intercepts. I tried, there are no x-intercepts. Is it still a parabola?
Yeah.
Okay, can anyone tell me, is it opening up or down? Up, but I can't let it touch the x-axis. There are no x-intercepts. We tried by quadratic formula, there are none. And if you say, Professor, where's the graph? I'm gonna ask you to go through the negative b over 2a and all that business and actually get a good graph. But guys, the graph, you could go through and find the vertex and all that and graph it, like we've been graphing earlier, you could do that. But I know for sure it's opening up, put it in green. It's opening up, I cannot let it touch the x-axis. So it's gotta be opening up in here somewhere. Because I have it opening up down here.
What do you?
Why can I not place it down below?
Oh, it's below the x-axis.
What happens if I place it below? It's still opening up. But what's wrong with this one?
It has x-intercepts.
It will eventually come up
And we'll cut through the graph.
and it's going to have x-intercepts. When we said, no, you don't have any x-intercepts. The quadratic formula didn't work, Professor. So can I ever have the opening up down below? Am I guaranteed without going through the vertex formula and all that business? Am I guaranteed then the graph of this must be above there somewhere? Always? Yes or no?
Yeah.
Okay. Now, therefore, would this now satisfy this? Is this always gonna be above the x-axis,
Yes.
which says greater than 0? Okay, so everything works here. All real numbers works here. And at the same time though, you have and you gotta satisfy this. What do you think the final answer will come out to be? What satisfies both?
Negative infinity.
Hang on.
No, it would just be.
What do you think will be in both? I know this is gonna be here in this one. If this one has all real numbers, is it also picking up this?
Yeah.
So is this piece gonna be in both? If I say all real numbers, would that pick up that green over here? If I say everything works. You know, that green's gonna be picked up over here, because everything works. And is it being picked up here? So is it in both? And therefore, there's the answer. Vanessa, strange problem there, she helped me out. A solution is nothing but -5 up to 3. That will satisfy this inequality. Wow. Now, that was a tough one. Johnson, I always calling you so much, I said Professor, talk to someone else. Mama, give me something outside here. If this is the answer, it should not work.
-7.
-7, that's not in there, -7 shouldn't work. Let's see, why not? We take -7 back to the original problem. -7 squared is 49. 2 times -7 is a -14. Guys, what? 14, yeah. So 49 subtract 14 is what it comes down to. What's 49 subtract 14? 35? What's the absolute value of 35?
35.
35. Is 35 less than 15? Therefore, it shouldn't work. You give me something inside here, guaranteed it's gonna work. Something caught between -5 and 3. Who has an idea it's just something?
-4.
-4. -4 is in there. Okay, -4, put it back up here, 16. -4 here, -8. So 16 minus 8 is 8. Absolute value retains an 8, it's 8. Is 8 less than 15? If you get outside that interval, it will not work. That's an unusual one, but Vanessa will help us out with that. Guys, chapter 2 is finished completely. Be ready. I know I just did this today with you, these absolute values, but with Corey's help, Vanessa's help, we definitely should now know understand how to set these up and get answers. Is that true? Okay. Now, I guess I called this part 1, part 2. Chapter 3, binary. Now, they start out with this. Now, I'm gonna do a lot with this. What on earth is a polynomial function? Professor. And sometimes in department meetings, when we have department meetings here, I suggest, please don't call this math 2, call it functions. Rename the class and call it functions. That's all we're talking about, the whole semester. Functions, 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 different types of functions. Now this one says polynomial. Let's reflect back to 3rd grade, maybe 4th grade. Does anyone recall anything that you may remember back whenever, that when they used the word polynomial, something that you can recall mentioning back then?
More than 2 terms.
So again,
More than 2 terms.
it could be more than 2 terms, it could be 2 terms.
Oh, yeah.
And
It
it's
could
more
be
than
1 term. Now, does anyone remember when this was talked about back in middle school probably? We're not gonna do as much as we're doing here with it. There were 3 specific ones that most instructors would have you, and they wrote the names down for you to identify particular polynomials. They like the one that has only 1 term in it. They like the name for the one that has 2 terms in it. Then a name for 3 terms, and they usually stop at 3. Does anyone remember any of those names?
2 and 3 are
Trinomial. Trinomial has 3.
Monomial.
Binomial, oh, beautiful. Binomial has 2. And
Monomial.
binomial got that one. Does anyone recall the one that has only 1 term? The name they gave.
Nope.
So they start out with a monomial, this way. Guys on the side here, 1 term. This has 1 term. You say, "But that's what it means." That's what
Mono.
you can have just 5. That's a monomial. Or you could add something with it. Maybe 5x squared y to the 4th. That's considered just 1 term. Monomial. If they want you to maybe now look at something called a binomial, as I heard, all these 2 terms. And guys, my good example maybe use something like we're working with here, x squared plus 2x. That's a binomial. 2 terms. Trinomial. I heard that mentioned. Of course, we have 3 terms. And to make it more in line with what we're doing here, you can say, oh, Professor, right, this is 3x squared plus 4x minus 2, you have 3 terms. For example, trinomial. Now, have you seen, I'm sure you have seen maybe one with 4 terms? Of course you have. 5 terms? Of course you have. Now, have I, in my experience, seen one that runs forever? I have. terms just keep going. Okay, so right now, monomial, binomial, trinomial, maybe 4 terms, 5 terms for us here in chapter 3, all are grouped together and called polynomials. Jonathan, do me a favor. Did I give you from the textbook the standard form, what a polynomial function looks like? P of x equals, they use a P.
Yeah.
Okay, hang on. So all together, guys, this takes care of all of them. Now watch this, I don't want to scare you. Break it down for you. Tell me, what does a polynomial function look like?
Yeah, so it's P of x equals a n
Subscript n.
subscript n x to the n.
Hang on now. You stop right there. That right there, if he stops right there, that's one of these. That's one term. That's a monomial. They said, no, professor, we're gonna take care of all of them. Now what they say, plus what?
Plus a subscript n minus 1 x to the n minus 1
Okay. And what does it say next?
plus a subscript n minus 2 x to the n minus 2.
Okay, if you stop right there, you got a trinomial. He said, no, professor, we want something that can cover all of them. And then I think because it's so large, they may have at this point put dot, dot, dot,
Yeah.
just to show there are more terms, because it's a large expression. Then plus they picked up with and wrote out for us probably what?
A, is that subscript 1 as you would say, or
Okay.
x plus a to 0,
Subscript 0.
subscript 0.
Woo! Now here's the issue. When you leave me, and you go to that math 7, and sometimes it depends on the instructor. And it also depends on the course, it depends on the school. When I was first going through my math in college, I'm all doing a little bragging here. I went through high school and I thought high school was a breeze. I loved high school. Loved high school, took all the math courses they offered. Had one of the best math teachers ever teaching math, which influenced me to teach. And I liked it so much, and I liked school so much. I graduated valedictorian. So I got to make a speech at graduation. Leo, well, I felt good. I felt good. We got off to, ready to go off to college, and my parents dropped me off on this huge campus, and I was like, whoa, I love this. We had 55,000 students on campus. I loved it. I said, ooh, I don't want to go home. I'm going to stay right here. So then I started taking my math courses and other courses. And I thought, Ramsey valedictorian, that something's changed. All those A's that I was making, I was getting some papers back that I thought, ooh, if my parents see this, oh no. I said, what's wrong? One thing was wrong is that there was more competition. There were some students coming in there already prepared, well beyond what my school prepared me, which was a good school. But some schools go beyond. Some schools just do it differently. I had to compete with that. Therefore, going into that math program, I'd sit there and I'd say, well, darn it, I graduated valedictorian. I said, why don't they just give a degree to me? I'd like to stay here 4 years. And then do graduate work there. Why? I'm so smart, why don't you just give me the degree? Let me go. Well, I found out it was a struggle. It was a struggle. I had to get my act together. It wasn't a little smooth high school, walking down the hallway in high school saying hi to everybody, my friends, and smiling at the teachers. No. On a huge campus of 55,000, no. You're not gonna walk down on campus, hey, how you doing? They think you're crazy. No. Changed. And all of a sudden, I take my first calc course. That's where I first took my calc course. My first calc course, and sure enough, I recall, that was the first day mentioned to us that I had never seen anything like that, expressed like that in my life. I'd heard the word polynomial. I heard that, and I knew how to factor. I knew how to do all that math stuff. But when I got to college, the professor there puts this on the board first thing. And we all looked at each other like, what? Welcome. Welcome. And he expressed a polynomial function, which I had never seen expressed like this. So Johnson, we're gonna break this down and see what on earth it means. Okay, now guys, they say all of them look something like this. So if you took the first three, that's a trinomial. You go pick up another one, and the other one, guys, the way they have it labeled, probably would be a subscript n minus 3.
Yeah.
X raised to the n minus 3. And it continues like that. And they're gonna say more than likely, eventually, you'll end up with just something with an x in it. 2x, 3x on the end here. And then probably more than likely something on the end, which might be a constant, a number without x. They'll say, if that meets that condition, it's called a polynomial. Now, before I jump into and try some of these, I'm gonna make it easy though. They identify this a subscript n, this is notation. This is called the leading coefficient. Leading coefficient. By the time I got to college, I don't know whether I could spell the word coefficient. All of a sudden, what's that? Leading coefficient. Then all of a sudden they say a subscript n minus 1 is like a placeholder. They're saying there could be another number. There. And down here, a subscript n minus 2 is like a little placeholder, another number. Jonathan, this, we know, represents the degree.
Yep.
I've used that word in here. That's the highest exponent. So it could be a cubic, a quartic, quintic, all those names are given to it. Could be a number up there to represent the degree. And then they're telling me if it's in order, it drops down as you go through it. That degree drops down. Now, does anyone remember the word that most teachers use back in middle school when they say put in a certain order? Most teachers probably ask you to put in a, does anyone remember what particular order most teachers were asking you to put those polynomials in back then? I bet they use the word a lot. Say, don't turn your work in until you have it in a certain order. They don't want all this mixed up. In
Highest
other words,
degree, right? Wasn't it the highest?
I think you guys with this. They don't want this.
It was the highest degree. to the
They don't want
lowest.
that. They want some order. And what? They want the highest first, then you go down, and they call it descending order. They want the exponents to be in descending order. Put some order to it. Okay, so it's in descending order, guys. If you start at the end, this is the highest, it drops down one. It drops down again. It drops down again, and pretty soon you may have no x at all down here, and that's why they call this, when you finally reach it, if there is one, a constant. No x with it, just a number could be on the end. So that's a description of what a polynomial function looks like. Okay? Now, what I did, Jonathan, you should sort of follow and see if I did the same thing here on that handout. Let me see if I did. Hang on. Oh, I did. Guys, I jumped right into and have this. Before I write out a particular example I will look at, they did place a restriction on this n. The degree must be this type of a number. Don't let n be a negative. Because n, the degree must be greater than or equal to 0. I should point that out for I jump into my work here. Okay, Jonathan, I don't think I placed this on the handout, but here goes. I'm gonna write my first example of a polynomial function. And I brought in this one, which I think is cute, 4x cubed, subtract 3x squared, subtract 4x, plus 3. This one has 4 terms. What is, and they give a word here, what is my leading coefficient understood to be on this 4? My degree is understood to be 3. And I placed it in descending order after that. 3, 2, 1. And I got a constant on the end of 3. That's a polynomial function. Now, before I jump into it and do something with it, please tell me, Leo, You have an exam tomorrow. Your exam covers mostly quadratics tomorrow. Please tell me, suppose I've written this. I'll just make up one real quick. That's a quadratic. Can I also, based on what we're doing now in chapter 3, can I also say, Professor, that also could be identified as a polynomial? It's a trinomial. It can also now be given the name polynomial. We can call it quadratic, it is a quadratic. It's a polynomial also, it's a trinomial. Leading coefficient 4, degree 2, constant 6. Now, I know what this scratch into. You know what this scratch into. This scratch into a parabola. And tomorrow on the test, you got to put it in vertex form, like I did my first example today. Vertex form and graphic. I know what graphs should do. Does anyone think they know what that one graphs should do?
That doesn't go
Like a wave?
like a snake.
Like a snake? Okay, I'll.
Well, actually, wouldn't the parent actually know?
Talk to me about it. Yeah, tell me, what do you think? That's a parabola over there for sure. This one, John can give some good insight. What do you think maybe, I haven't graphed it yet. It's a polynomial function, has 4 terms, degree 3. It's not a parabola. What is it then? Here we go.
Is it kind of like a parabola, but the left side is, flipped around the x-axis?
I don't think so. Try to visualize what you told me. Okay, now, if I don't know exactly what it looks like, I'm taking more.
It almost looks like a stretched out S, but you rotate it 90 degrees.
A stretched
It goes
out S.
down from negative infinity, over the origin, and then back down.
Oh,
Or, sorry,
hang on.
down through positive infinity, through the origin, and then down through.
Mr. Mathematician, are you saying something like that?
Yeah, kind of.
That's a cubic.
Well, now, I know the parent, now there's the parent function for cubic.
Yeah, that's what.
We've seen it, right? And this thing does have a cube in there. So hold on, wait, Jonathan, you just gave me some insight. Mr. Park, this is being recorded, right?
Mm-hmm.
Geez, it's nice today. You tell me, wait, Professor, before you jump into it, show us what it really looks like and all the detail involved here. You say, wait, Professor, I see an x cubed, or the highest, is 80. And I know, Professor, I'm going to do it right now since he mentioned it. I know from a handout or something that x cubed graph looks something like that. Is that true? Just a quick glance at it? Okay. And I understand why you guys are saying, well, your graph, Professor, looks like it's extended. It's got 4 terms, but should it look like that? Well, let's go look a little bit more. Now, can anyone tell me how would you, as a clever student, get a start on getting the graph? For this first polynomial function, 4 terms, cubic. What would you do in the attempt to get the graph?
Should we find the x-intercepts?
Tell me again.
X-intercepts?
I'd find the x-intercepts, if there are any. If they're not, we're in trouble. So she said, Professor, set this equal to 0, as always, and solve and find the x-intercepts. Now I gotta solve it. Anyone have any clues on how to solve that?
The degrees need to be subtracted.
Oh, whoa.
Oh, you could factor it too, yeah.
Wait, when you say factor, like factor how?
Oh, no, you can't factor out.
You can't factor directly.
What did
You got 4 terms.
When you subtract all the degrees?
I see, Mana tells me, Mana.
Should we group them two
Okay,
and
but
two?
usually if it's 4 terms or more, you try grouping. So she says, Professor, you can't group all, or factor all this at one time. She says, maybe group the first 2,
Oh, yeah.
I'll squeeze that in, and the last 2. That's usually the way we group. Sometimes grouping is a little different. Guys, now in this grouping right here, definitely I can do a little factoring. I can take out a common factor of x squared, I think, help me out. four x minus three. I gotta check my factor myself, looks good. Now what can I do down here in the negative four x plus three?
Factor out one or negative.
Factor out, well, not just a one,
Negative.
negative one. I'll be careful with the sign. If I factor out a negative one, guys, look what happens. You can rename that in part as that. This and this are equivalent. And we really lucked out here if all that's correct. Because I can see now additional factoring. What else can I do now to make it even look better? Is there a common factor?
Difference is square.
And the common factor is what? 4x subtract 3? Take it out. And guys, if I take it out, look at this, I'm left with x squared minus 1. Darn it. We'll factor further.
Yeah.
Yeah, x squared minus 1 is a what? Difference of squares. So we'll factor a difference of squares. This factors into x minus 1, x plus 1. You may turn those around if you wish. There, finally, it is factored. And if I split this up, and I'm careful with that zero product property, or solve this, guys, and real quickly, we've done so many of these. This is 3 over 4, no problem. This is 1. This is negative 1. And I prefer this written like this. That's my x-intercept. This is an x-intercept. And this is an x-intercept. Let me go ahead and place those on the grid right now. So my graph, whatever it looks like a snake, I heard. It looks like something else. Whatever it looks like, it's got to pass through those points. So guys, I got 3/4 0. Place 0 right here for a reference. And 1 here. So we'll place 3/4 right close to 1. Right there. You squeeze that in. 3/4. And I got 1 0. Oh my goodness, it's right close to 1. Let me squeeze. Bring 1 out a little bit. There's 1. And then negative 1's on the other side. Step back and make sure all those are marked. Okay, negative 1, 3/4, 1. Guys, did I mark those correctly? The x-intercepts?
Yep.
Okay. Y-intercept, a little easier to find, thank goodness. That's merely find p of 0. And if you go back and replace 0, and all these x's by 0, guys, I see it right there. You're gonna get a 3. And let's put like that, 0, 3. That's my y-intercept, so it's up here. And that's my y. Let me put it in red since I'm using it here. That's my y-intercept. Jeez. Everything's true. I don't have the graphic yet, but those are the x and y intercepts. Oh boy. Oh boy. If I ask a student to come up and connect, here's some possibilities. You said, Professor, you said this right here was like a parent graph. So maybe it goes up like this, Professor? Picks that up, goes up here, and where's it gonna go? It's gonna go on like this? No, it's gotta pick up these 2 points. So there's more going on with this besides just x cubed. Can anyone tell me now a clever way to see what does this graph really, there you go, look like? I would turn to sign analysis. I would turn to sign analysis, and on the side here, I would do this to see what this graph looks like. Guys, on the sign analysis, I'm gonna place those numbers we have, 3/4, 1, negative 1. Let me put it like this. I will say yes, they're included. Those are my so-called critical numbers. And then start sign analysis. Now bear with me. You're gonna help me. Okay, this I'm gonna test. This I'm gonna test. 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 Guys to the left of -1, I'm gonna try -2. We'll go through the details here. Between, we'll try 0. That'd be nice. Between 3/4 and 1, that's awkward. Guys, does anyone know a number I could test called between 3/4 and 1?
7/8.
Well, 3/4 is 0.75, so I can't use 1/2.
7/8.
Oh, 7/8, cause this right here would be 6/8. Okay, 7/8. And out to the right of 1, my goodness, I'm gonna try 6. Okay, guys, here goes. Where am I testing with that sign analysis? I better go back to my factored form, which I think we finally got somewhere in here. Was it this, guys? I'm all over the board here. Was that the original factored form? Put it up here. 4x subtract 3. X minus 1. X plus 1. I think it was the factored form, yes. Okay, Jonathan, here goes. I'm replacing my -2. X by -2, I think it makes that a negative altogether. -8 minus 3. So I'll put a negative here. -2 put in here, -2 subtract 1, -3, another negative. -2 here, -2 plus 1 gives me another negative. All together, negative. I'll come back to it. Let's try 0. 4 times 0 minus 3 gives me a negative. 0 minus 1 gives me a negative. 0 plus 1 gives me a positive. All together?
Positive.
Positive. I'm trying 7/8 with Eric's help. Oh, geez. Okay, 7/8 right here, guys. I'm doing my math in my head here.
Negative.
Oh, is it negative altogether?
Negative, positive, positive. I think.
Okay, now I'm gonna trust you. Okay, negative, positive, he tells me negative?
Negative, positive, positive, no.
7/8 minus, this should be negative right here. I better check the work here.
Oh yeah, 7/8 minus.
That should be negative there,
Negative, positive, negative.
and this should be positive. How about the first one? The first one bothers me, 4 times 7/8,
Oh wait, no, sorry.
right?
This is 28 over.
That's, let me cancel. It's 7/2. That's the fastest way to do it, cancel 4 and 8. You guys with me? This one just slows down a little bit. So I got 3.5, subtract 3, is that positive? 7/2, 3.5, subtract 3, so that's going to be a positive. And I think the other numbers are okay, when I put a 7/8 in, they are. All together?
Negative.
Lord, I hope so. Okay, 6. Positive, positive, positive. That would be, which gives me a positive. Now, here goes. Let me get my green marker. Get the graph. Guys, to the left of -1, right here's -1 on my grid. We've decided it should be, came up to be a negative by sign analysis, which means the graph should be where? Below. So it's below, so it's below. I gotta come up and pick up that point. Does that look somewhat like the x cubed graph right now? Okay, at least on that end. That may change. Now between -1 and 0, right here, or the -1, not -1, 0. -1 and what? 3/4. And that came out to be, we tried 0, we got a positive. So it says, where is it headed? It's got to be above. Okay, now as it's above, guys, does it have to pick up that?
Yes.
Okay, so it's got to come up and pick up this, and whether it picks up it directly, we might think it does. It's got to come back down, and please tell me, does it now pick up 3/4 here? Yes or no? Is that true? Is that okay? Is that above?
Yeah.
Okay. Now between 3/4 and 1, we tested and got a negative. So where is it? Does it drop down? Something like that. Let's see what happened here. Jeez. What happened here? Positive? Oh, it's got to turn then somewhere down here and do what? Oh, whoa.
Come back up.
Come back and pick up my 1, right? I've got the 1 there. Oh, jeez. Guys, is that it? right on top of the board there, does it look like something like that? Did I pick up all the intercepts?
You did.
That's true. And then based on the, where it's supposed to be located, above or below, we got that, yeah. That's beautiful. Here we go, here we go. Good question, yeah.
Did he ask how?
Exactly. Oh, boy, you guys are ready for Math 7 right now. Say, Professor, this sort of looks like a parabola. In essence, you'll find it's not. It takes that form, looks like the shape of a parabola. This one looks like a parabola, or almost looks really like a parabola, right? Opening down?
Yeah.
It really is not. It's part of this cubic graph, it sort of just takes that form. Now, can I find this maximum point here? We might think it's 3. We don't know yet, because this could happen. I'm not gonna erase, I'm gonna erase the shape and come back to it. This could have happened. I could have made the graph do this. Go above, then come back and pick up that. It could have done that. It could have gone a little higher than 3, then turned and come back. We don't know. It could have done that. So this maximum, wherever it is, guys, go back here. Show what it might have been doing. Watch me mess all this up. Okay. Guys, there's a max in there. I agree, there's a max in there. There's a min down there, right? Now, can we find them? No. Can Park and Anna find them? Yes. Park?
Yep.
Okay. Now, all he has is this. That Anna, she would say, Professor, I can take this right now in the red. Do a little calculus on upper recalc. Do a little calculus, Professor, I can tell you exactly where that point is supposed to be.
Take the derivative.
There you go. And this point down here, I can tell you exactly where that point should be. So you'll know exactly how far down to drop. Right now, we don't, so we'll just get a rough sketch of what it looks like. So step back, guys, look something like this. Now, can someone tell me, as I'm getting ready to close this down pretty soon. Can anyone tell me what role did that x cubed graph, the black graph, which does represent this, what role does that play here? My green graph is the graph. But you guys said something about x cubed, because you see an x cubed, I see an x cubed also in that first term. What role was it playing? I placed it on there just to know what it's doing. And it is doing something. Look at it closely. It's doing, tell me something about that graph, the green graph. It is telling me something about the green graph.
Is there another intersect?
No, something a little easier.
Is it oscillating? Is that what you said?
No, oh, it is oscillating, for sure. Something else though. That black graph is telling me something about my green graph.
Oh,
The
the
direction
same
is going,
domain.
Oh, whoa, tell me more.
the direction is from negative
So
infinity.
you're telling me the black graph was falling down like this.
Yeah,
Was my green graph, when I finally graphed it, was it doing the same thing over here on this end?
yeah.
That's behavior. Behavior in the
And,
graph.
oh, and behavior.
It's called the behavior.
And behavior.
And how about here? Was the black graph going up like this?
Yeah.
Was eventually my green graph doing the same thing?
Yeah.
So out on the ends, they call it end behavior. That's what that parent graph shows the graph should be doing. That's all it shows is what's happening out on the ends. They should behave the same way out on the ends. But the graph itself is that crazy green graph. Wow. How's that look? That's just a little start. Watch my time here. It took me a little time here. That's just a start on this. Now, to close down, I'm still concerned about that test tomorrow. Let's say something here. Oh, boy. Hang on, guys. Okay, here we go. If I'm down here on this side of the board here, can we all see it? I'd like to leave all this on the board. Corey, can you, okay if I go down here? Okay, last one. I will do it fairly quickly, may not completely finish it up. All right, this is P of X, P for polynomial. I made this one, look, it looks a little simpler. This would be a binomial. They want to sketch it. It's 4x to the fourth, subtract x squared. 4 x to the fourth, subtract x squared. And they want us to sketch it. This one might be a little bit easier. The leading coefficient is 4. The degree is 4. There is no constant. Only 2 terms. Guys, if I go through the same routine as I did on that last one, you guys first I think said factor this. Let's take out an x squared. Common factor. Do not let me mess up. You got an x squared. Can I do additional factoring?
Yes.
Can anyone tell me about difference of squares? What would the additional factoring look like?
4x,
Ah,
no, oh, 2x, sorry.
2x.
2x minus 1, 2x plus 1.
Perfect. Perfect. There it is factored. Now let's do the same routine, which will take a little bit, move a little bit faster than I did on the last one. Jonathan, I'm gonna graph this one also. I wanna see what it looks like, next to the fourth. Okay, now I don't think on the parent graphs, I don't think I showed you what next to the fourth graph looks like. X cubed it did. Okay, so we'll just go for it. Okay, guys, go to a grid. As efficiently and fast though as I can. And can anyone tell me where are my x-intercepts right quickly and I'll plot those?
0, 0.
0, 0 for sure. Let me do this, get this reasonable. Okay, zeros on here, and,
For x to the fourth graph?
yeah,
Oh,
right here.
sorry, it would be negative 1/2 and 1/2.
Negative 1/2 and positive 1/2. We'll put those on there. These are my x-intercepts. And 0. And positive 1/2. Done. Y-intercept, right quickly, since I'm closing down. If you go back and replace all the x's by 0 and crunch it out, I think you're gonna get 0. So there's my y-intercept, we can find those real quickly. Now, here we go, and we'll close this down. I'd like to, quickly, with your help, test here, test here, test here, test there. Sign analysis. Guys, to the left of negative 1/2, I'm gonna show it quickly since we're closing down. I'm gonna try negative 2. Don't let me mess up. I'm replacing the x's by negative 2. That's my choice, my number. I get a positive 4. Negative 2 put in here, I think gives you a negative 5. Negative 2 here, I think gives you a negative 3. I hope I did not mess that up. If that's true, all that is positive. What does that tell me is happening to the left of negative 1/2 on this graph that I'm looking for? Where is it located? Is it above? It's above. Now, I don't know exactly what it looks like, a little curve to it probably, but it's above. I'm gonna make it look something like this. A little curve to it, just show it's above. We don't know exactly how it curves. Now, in between these two guys, between negative 1/2 and 0, here goes, my goodness. We'll try negative 1/4. Let's put a negative 1/4 in there. Square, positive. Put that right here. I'm trying negative 1/4. Positive here. 2 times negative 1/4, that's a negative 1/2 minus 1, we'll get a negative. You guys can check out that later. 2 times a negative 1/4, negative 1/2 plus 1 gives me a positive. Altogether is negative. You guys can check that out later. So between negative 1/2 and 0, my graph is located where? Below. Now how far down does it drop? I don't know. Anna and Park would know. I don't know myself right now. They would know. They just sat down and did a little calculus. Okay, I'm trying 1/2 of between 0 and 1/2. Let's try positive 1/4. Of course, you're going to get a positive. Go back. Squeeze it in right here, guys. Positive. This is 1/4. 2 times 1/4, 1/2 minus 1 is negative. I don't want to mess up here. There, I think we'll end up with positive. Altogether is negative, which tells me what?
Under that.
It's under. Jonathan, this is the way I'm in the class today. That says the next part of your graph, professor, is under. It's turning, dropping down, how far down it goes, I don't know. And on Parkwood, but it's down below. It's got to come back up and pick up that x-intercept. It's a strange looking graph. And then finally out to the right of 1/2, guys, I'm gonna try 2, positive. Put a 2 in, positive. I think they're positive all the way across, I think. Which means out here, where's the graph located? Above. I made a little curve to it. There's your graph. Not drawn to scale, no way is it drawn to scale. But, Park, do me a favor before we close down. Guy, could you graph this for me real quickly, either in the original form here, it might be best. And just see what it really looks like. I think we're pretty close to what it looks like. Just based on some things. 4x to the 4th subtract x squared.
X squared?
Yeah, what does it look like?
Just plug in decimals, right?
Yeah, it looks like
Yeah. It's
same.
symmetrical.
Is it something like I have over here?
Yeah.
It does, looks something like I have over here. Mark, I have something coming down like this, Anna, coming down, fix that up, comes back. Now, does this piece here fall down below, lower, which piece is lower down here? This one?
it's
No,
same.
the same.
Oh, this, oh,
They're
this is about the
symmetrical.
same.
Yeah, it's
Yes.
even.
Oh, I see, so sometimes that can happen, I wouldn't know that until I use calculus. They both drop down the same amount, maybe, yeah.
So you were talking about the parent graph, and how for our x cubed and our x to the 4th, they both follow the same end behavior.
On the end,
Would it not be valid in that case to just ignore the left and right x-intercepts, since we already know that the parent graph for x
that
cubed is gonna be
that's my
lower?
lesson tomorrow. That's my lesson tomorrow. Now, how many students think they know what x to the 4th, which is not on that parent graph that I gave you guys, the handout? Not x cubed. Does anyone know what x to the 4th might look like? Just x to the 4th. As a graph, I'll put it on the grid here to
A
see.
slightly more square parabola.
It's like x squared squared.
Yeah.
So it's gonna take somewhat like a parabolic form, not quite a parabola. So it's gonna take somewhat like a parabola, and, oh boy, watch me mess this up. So I would say it looks like this. If you say parabola, it may look something like that, I don't know. Is my red graph and the green graph, if it does, are they doing the same thing out here?
Yeah.
On this end,
Yeah.
both rising? And are they doing the same thing out here? Are they both rising also? There's that end behavior. So the parent graph. Let me stop. Jeez, I'm getting carried away here. Oh, I should stop. Now, we have a test tomorrow. You guys know what the test covers. The sections are listed right there. And I went through a little bit of a review at the beginning of class. I'm gonna give you 2 hours. No, not 2 hours. About an hour and 45 minutes, maybe an hour and 50 minutes, something like that.
It'll be towards the end, right?
Yeah, always at the end. And why do I do that? Because if you need more time, we're here. I can stay a little bit longer with you if you need more time, beyond 3:20.